What up, fellow chemists? I'm Abe Purcell. Today we're going over ionic nomenclature. Nomenclature is how we name chemicals. So let's get into it. So what is an ionic compound? It's a cation and an anion. You get a positive ion and a negative ion, and you make the compound. It's as simple as that. Okay, on to the formulas. It's pretty simple. You take a cation and an anion, and the anion has an ending of IDE. So for example, potassium ion and iodide ion make potassium iodide. Now the anion are usually ends in IDE. Some examples: oxygen becomes oxide, fluorine becomes fluoride, and chloride, bromide, iodide, sulfide. Onto multiple ions, where it differentiates between covalent nomenclature and ionic nomenclature. In a covalent nomenclature, you'd see a di in front of it because there would be two chlorides and calcium chloride, but because the charge implies that there will be two chlorides to meet the +2 calcium charge, you don't specify it, and it's just called calcium chloride. Okay, for polyatomic ions, it's very simple. The cations, nothing happens. You just call it, if it's an ammonium ion, you just put ammonium at the beginning. If it's a nitrate ion, you put nitrate at the end. If it's any polyatomic ion, you put the name of the polyatomic ion there. Now you may be thinking, why isn't it nitride? Or why is there no IDE at the end? That's because the name of the ion is not nitride ion, it's a nitrate ion, and that's why polyatomic anions don't contain IDE. On to transition metals. This is where it gets a little bit tricky. In iron and copper and most transition metals, they contain two or more different charges that they can be in, and that changes the ionic compound. So iron 3 oxide and iron 2 oxide are different. The way to specify it is using a Roman numeral. The Roman numeral always refers to the cation, so iron 3 oxide would be different than iron 2 oxide. Copper 1 sulfide would be different than copper 2 sulfide. I hope you learned something today, and thanks for watching.